Hey there, Kipsters. Mr. Piazza here, and we're looking at objectives 3C.5-7. It's all about the Pythagorean theorem. Pythagoras was a Greek mathematician who discovered this relationship between the sides of a right triangle that said, if you know the length of one leg and you know the length of the other leg, the length of the hypotenuse is always the sum of the squares of the legs. So if you take a squared and add that to b squared, it's going to equal c squared. And that's what the Pythagorean theorem states. You're going to be able to use that relationship anytime you see a right triangle. So I have two problems that we're going to complete here using this relationship, because in both of these I see a triangle that is a right triangle. And that's my cue to tell me that I can use this relationship that Pythagoras discovered of a squared plus b squared equals c squared. So the key is to be able to identify what side of the triangle is A, B, and C. So first, I'm going to look at 72, and then you're going to be working on 73. Looking at 72, in the figure below, D is the midpoint of AC, and BD is perpendicular to AC. What is the length of BD? So I'm trying to figure out how long is this piece of the triangle. For me to figure that out, I already know how long this side of the triangle is. And I don't know exactly how long this piece of the triangle is in red, but I think I can figure it out. If this whole piece is 30 centimeters and D is the midpoint, that must mean that D cuts AC in half, and this should really be 15 centimeters. And so at this point, I know the red, which is 15, I know the green, which is 25, and I'm looking for the blue. So for me to identify, or to use the Pythagorean theorem, I have to be able to look at this triangle on the right side, this triangle, and identify which side is A, which side is B, and which side is C. That's pretty easy because C is always going to be the hypotenuse. That means the longest side, which is also the side across from the right angle. So if I draw a line from the right angle across, the hypotenuse is 25 centimeters. That's going to be C. Other than that, A and B are both my legs. I'm not sure if you can see that. I'll write that here too. A and C are both my legs. So it doesn't matter which one I label A or B. I can switch them either way. For the sake of this problem, I'll label this A and this B, as long as I have C as my hypotenuse. I'd like you to stop the video here so that you can label the sides of this triangle in 73. We haven't solved the problem yet, but the first step is just to label them. So please copy down the triangle 73, label sides A, B, and C. Press play when you're ready to check how you labeled it. Okay, looking at this triangle in 73, you wanted to first label side C, the hypotenuse, and you should see that the side opposite the angle, which is the opposite the right angle, which is the longest side, has to be C. And there's two ways you could have labeled it. You could have labeled it A and B. You could have also done B and A. But whichever one, you just need to stick to one and go with it. For this one, I'll actually label it like that. B and A. As long as C is my hypotenuse, you're good. Coming back to 72, now I'm ready to solve it. I'm going to write my Pythagorean theorem of a squared plus b squared equals c squared, and I'm going to plug in the information from the triangle to be able to solve this equation. So A, I don't know. That's a squared. B, I do know. That's 15 squared. And C, I do know. That's 25 squared. So if I can solve this equation, which is something you reviewed in the video 3C.4 just before this, I should be good. So a squared stays the same, plus 15 squared, which is 225, equals 25 squared, which is 625. I need to cancel my constant by adding the opposite. And after I do that, I have a squared, b is canceled, equals 625 minus 225, that's 400. Find the square root, because I have a squared and the opposite is finding the square root. And that means A must equal 20, which is answer choice D. The length of that missing side, A, is 20 centimeters. Now it's time for you to try. I'd like you to substitute the values into the Pythagorean theorem so that you can solve to find the length of that missing side, YZ. Stop the video here, press play when you're ready to check the answer. Okay, you've tried, so now it's time to check. Again, the way I've labeled it, I don't know what A is. I'm still trying to figure it out. Plus B, that's 8 squared, equals C squared, which is 17 squared. My computer froze for a second. A squared, I don't know. 8 squared is 64. And 17 squared equals 289. Need to cancel the constant by adding the opposite of 64. That means my constants cancel. A squared equals 225. I find the square root, and A is 15. And the answer is B. The length of that missing side is 15 centimeters. I hope you got that right. Okay, now you've had some guided practice on how to label a right triangle with sides A, B, and C, and then how to use the Pythagorean theorem to find the length of the missing side. It's now time for independent practice. There are 5 problems here which I'm going to label. This first one, what is the value of x in the right triangle shown below? The second one, the club members hiked 3 kilometers north and 4 kilometers east, but then went directly home as shown by the distinct line, dotted line. How far did they travel to get home? Then you have problem C. What is the value of x in the triangle shown above? Problem D. How high is the ramp? And then problem E. Find the length of the missing sides. If you know that the diagonal is 25, the diagonal is 25, and you know the width of the screen is 20. If you do well in these problems, you are ready for objectives, to retake objective assessment 3C.5-7. This is a really important key standard for the CST, so good luck.